Hi everyone, thank you for joining. Today we're gonna look closely at question 10 from your final examination grade 12 November 2021, and this is calculus. Okay, question 10. The graph of h of x is equals to ax cubed plus bx squared is drawn. The graph has turning point at the origin, that is at O, it's 0 and 0, and B, it's 4 and 32. A is an x-intercept of h, as we can see on the graph. 10.1 show that A is equals to -1 and B is equals to 6. All right, they want us to show that. So we are given in question h of x is equals to ax cubed plus bx squared, right? What do we know? We are also given the turning points, right? We are given the turning points. So we know that the first derivative at the turning point is equals to 0. That is, the gradient at the turning point is 0. Okay, because if you draw a straight line there, you will get a horizontal line, and that horizontal line definitely have no slope, meaning that the first derivative, which is also our gradient at the turning point, will be equals to what? Will be equals to 0. Okay, so we can use that information to be able to deduce the values of a and b. So what we can do, we are going to first derive this equation by using the rules for derivation. Power rule, it's going to be a times 3, which is 3a, and we subtract 1 on the exponent, we're left with 2. Then 2 times b, 2b, we subtract 1 on the exponent, we are left with 1, right? So what we can do is, we know that the gradient at turning point is 0, right? So we can say when x is equals to 4, h prime of 4 will also be equals to what? Will be equals to 0, because we are saying the first derivative when x is 4, that is the gradient when x is 4, there is 0, because the gradient turning point is 0. First derivative turning point is 0, right? Using that idea. So then we can now come and substitute where there is x. We can put 4, so it's going to be 3a into 4 squared plus 2b into 4. This is equals to 0. Okay, we can actually deduce our first equation is 4 squared is 16 times 3. It's going to give us 48a plus 2 times 4, which is 8b, is equals to what? Is equals to 0. We can actually make one of them the subject of the formula. Let's make a the subject of the formula. So this will be divided by 48 both sides. Okay, so a will be equals to minus 8 over 48, which will give us minus 1 over 6b. So this is our equation 1. Okay. All right, so how do we now get equation 2? Someone can decide to say, okay, I'm just going to use the same approach we use. We also have another turning point to say h first derivative when x is 0 is equals to 0. But the problem with this is that when you put 0 where there is x, you're just going to get an equation saying 0 equals to 0, meaning that that second turning point won't help us to get another equation, right? So we need to use probably one of the point on the graph and substitute it on our original equation to get another equation. Okay, so we can substitute b, which is 4 and 32, right? We know this is x, this is y, on the original equation on h of x. Okay, so we know that h of x is equals to what? Ax cubed plus bx squared. Okay, so we're gonna substitute b on our h of x. Where there is y, we're gonna put 32. That is our h of x. Where there is x, we are going to put 4, right? So we put 4 where there is x. So this is 32 is equals to 4 cubed is 64a, 4 squared is 16b, right? We can now come on this equation, we substitute, we can say but a equals to minus 1 over 6b from equation 1, right? From equation 1, a equals to minus 1 over 6b. So where there is a, we're gonna replace it by what? By minus 1 over 6b plus 16b. All right, so this will be 32 minus 64 over 16b plus 16b. We can use a calculator to get the answer of that, right? Let me just put it this side because of space. I'll just write it in red. So it's minus 64 over 16 plus it's not 16, right? It's 6 there. Sorry about that. It's minus 64 over 6, right? So this is added with what? Plus 16, right? So it's gonna give us 32 is equals to 16 over 13. 16 over 13 over 3, right? Sorry, 16 over 3b. So to solve for b, we can multiply by the reciprocal of that, which is 3 over 16. What we do on the left must also be done on the right. So 16 and 16 they cancel, then our b will be equals to 3 times 32, which is 96 divided by 16, which will give us b is equals to 6. All right. Okay, so we have proven that b is equals to 6. So to prove that our a, we're just gonna replace our b with 6 and we're gonna calculate a, right? So our b is gonna be substituted on equation 1, then it's minus 1 over 6 into 6, 6 cancel 6. Then we can also see that our a is minus 1. Okay, so a is equals to minus 1, b is equals to 6. We have proven it using the knowledge of calculus. Okay, let's go to 10.2. 10.2, calculate the coordinate of a, right? Remember they told you that a was the x-intercept of h, right? So to get the x-intercept, so a is our x-intercept. What do you do to get your x-intercept? We let y to be 0, meaning that we are letting our h of x to be equals to 0. So that is our equation, right? After proving that a equals to minus 1 and b is equals to 6, then we can substitute and get the equation finally. So we can say minus x cubed plus 6x squared will be equals to 0. We can remove the common factor is x squared, right? Or someone can say minus x squared, it depends. Then you'll be left with minus x plus 6 is equals to what? Is equals to 0. Then here you'll be like x squared equals to 0, x equals to 0, or minus x plus 6 is equals to 0. Then when you take x to the other side, if you take x and transpose it, you'll see that x will be equals to what? Will be equals to 6. Then we can see that clearly this first coordinate x equals to 0 is for the first x-intercept. Then a, the coordinate of a will be 6 and what? And 0. Okay. 10.3, they say write down the values of x for which h is 10.3.1 increasing. Okay, so they want you to determine the values of x for which the graph of h is increasing. So how do we determine that? So we know that from this point, as we are moving down towards the turning point, our graph is what? Our graph is decreasing. So we can just indicate it like that. Then from this point till this turning point, right, our graph is what? Is increasing. All right. Then from this point going down, our graph is again what? Decreasing. All right. So for which values of x will h be increasing? We can see it's between this turning point when x is 0 and this point here, because this is the portion where our graph is increasing, where x is 4. All right, so we can say it's when x is between 0 and 4. All right, that you can include those points to say x greater or equals to 0, less equals to 4. All right, so it's between that interval. So that's actually how you determine that. All right, let's go to 10.3.2. All right, 10.3.2, they said determine the values of x for which h is concave down. right, for which x is concave down. So you can clearly see from the graph that this portion, right, the graph is concave up, and this portion, the graph is concave what? Concave down. All right, so you know that on your cubic function there's actually a point, right, and we call that point of inflection, right, point of inflection, where the graph will be changing its concavity, right, from being concave up to concave down, or from being concave down to concave up, right. So we know that at the point of inflection, which is the point where the graph changes its concavity, we know that the second derivative must be equals to 0. All right, so in order to determine the values of x for which the graph is changing its concavity, you can actually go and determine the second derivative equated to 0. So for x, that x that we solve will be called the x value on point of inflection. Or rather, in simple case, if you are given the turning point, such as in this case you are given 0 and 4, those are the turning point. You want to get the point at which the graph changes its concavity, you can just add the x values of the two turning point and divide by 2, right. You can actually determine that point of inflection, the x at point of inflection. So we say 0 plus 4 over 2, this will be 4 over 2, which is 2, right, meaning that when x is 2, the graph is changing its concavity. But they want where the values of x for which the graph will be concave down, right. So it's from this portion here. Let me just highlight it in red. This portion is the one where the graph is concave down, right, from the point of inflection where it's changing its concavity going this side, it's concave down. So we can actually say it's when x is greater than what? Than 2. That's the point. Also with your 10.3.1, where the graph is increasing, you can check it, but if you're just given an equation, how can you determine whether the graph is increasing? You must check where the first derivative is actually greater than 0 or equals to 0. When the first derivative is greater or equals to 0, then the graph is said to be increasing, right? But when your first derivative is less or equals to 0, we say the graph is what? Is decreasing. So you can actually use this approach for 10.3.1 to check whether the graph is increasing or decreasing, or rather you can use the method we use by actually going and highlight on the graph and check if you are given the graph. All right, last question, 10.4. They said for which values of k will minus into x minus 1 exponent 3 plus 6 into x minus 1 exponent 2 minus k equals to 0, for which values of k obviously will that equation have one negative and two distinct positive roots. And this is quite one of those questions that most of you learners leave it thinking it's maybe one of the hardest to solve. All right, but it's fairly one of the easy question to answer. You just need to look at the equation and look at how they've changed it, or rather manipulated it. Okay, so they want you to determine the values of k for which this equation will only have one negative root and two distinct positive roots. Okay, so before going and determining those values of k, you should be able to deduce what happened on the equation. Okay, so remember the equation for the graph was minus x exponent 3 plus 6x squared. But as you can look at this equation now, it has now on the values of x, right, it has now been affected, right? They subtracted 1 where there is x, meaning that they've shifted the graph of h of x by 1 unit to the right. Okay, so minus 1 means that they've shifted h of x by 1 unit to the right. Okay, so we can actually sketch a new graph of that is shifted by 1 unit to the right. Obviously, from having an x-intercept of 0, it will now have an x-intercept of 1. Here it was 6, right? So it will be shifted and it will go to what? To 7, right? Then the turning point of 4 also will now be shifted and it go to what, to 5, right? But 32 will still be 32 because they only shifted x, and I mean they didn't shift it vertically, all right, but rather horizontally. Okay, so that is our new graph, right? So you can see that our new graph now has now new x-intercept, and obviously it now has a certain y-intercept that is quite different from the initial one, right? So let's actually determine what is this y-intercept, because it's going to be very useful in solving this problem. All right, so to get that one y-intercept, so we can actually go back to this equation that has been shifted, -1 cube plus 6 x minus 1 squared, and actually go and substitute, and we can actually get the y-intercept, right? So if we let x equals to 0, then we can actually determine what is the value of y, right? So it's gonna be minus into x minus 0 minus 1 cube plus 6 into 0 minus 1 squared, right? So when you punch your calculator from the shifted graph, the y-intercept there is going to be minus into minus 1 plus 6, right? So it's 1 plus 6, and this will give us what? This will give us 7. So the new y-intercept is 7. Okay, so let's now go and answer the question. The question wants you to determine the values of k, and this is actually the vertical shift, right, up and down. So where your graph will have one negative root and also two other distinct positive roots. Let me just use a different color, maybe green here, to show you. So if you check, from which interval does your graph have one negative root and two distinct root? So that interval is actually the interval where your value of k must lie, right? So that's basically how you answer this question. Look at the red graph that has been shifted 1 unit to the right. So if you check the interval, here it is what? It is 32, right? So if you cut your graph here, how many roots do you have? You have one root that is negative because it's on the negative side, and you have two roots here that are what? That are positive, right? I mean, here you have, if you cut it on 32 there, you obviously have two roots, but they are similar and they are both positive. And here they say two distinct roots, right? Meaning we have to go down now. So if you cut going down, you can see that you're going to have one root that is negative and two distinct roots that are what? That are on the positive x-axis. Can you see? Also, if you cut going down like that, there one root that is negative, this side is to be positive, right? So as you go below 7, you start to see that you actually get three roots that are what? That are all positive and distinct, and the question said one root must be negative and two must be distinct positive, and it's actually above 7, right? So let me just show you properly. Let me delete this. I think it's quite a mess now. Let's see. All right, so you can see that when I cut above 7 and below 32, I'm actually getting one negative root and two distinct positive, because this side is becoming negative root, it's only one, and this side is cutting two roots and that are positive and that are different. Okay, so meaning that our value of k must be between 7 and what? And 32. It is between that interval that we are getting one root that is negative and one root that is positive. But it was also very, very important for you to first check the equation. That was the trick part of this question, that the equation had been shifted 1 unit to the right. Then you had to deduce that actually there's going to be a y-intercept there. Then you had to calculate it, and actually you just draw your line, vertical line there, and check where are you getting one negative and two positive, between which two intervals. Sometimes they can say all three distinct roots, right? Then that are positive. So you'll just check your interval, you draw your line where you are getting that thing, you just give them the interval. Very, very important. Okay, so that's basically how you solve this. All right, otherwise that's all for me, grade 12. Thank you very much for joining me today. If you're new to this channel, make sure you have subscribed and also you have hit the notification bell so that you may be notified when we upload new sessions. Otherwise, that's all for me, and goodbye.